Astrophotography isn't about aiming, it's about tracking. And it all starts with the right mount. Welcome to Edisla's ultimate guide to astrophotography mounts, where we break down the gear that truly matters. From time-tested worm drives to compact harmonic systems, from real-world struggles like the AM5's RA problems to a new wave of Chinese innovations changing the game. And don't miss our own field-tested insights at the end, because in this pursuit, precision isn't a luxury. It's the rule. Let's begin with the basics. At the simplest level, telescope mounts are responsible for two things: positioning your scope and tracking the motion of the night sky. Because the Earth is spinning, the stars appear to drift across the sky. To photograph them without trails or blurs, your telescope needs to follow that motion precisely. And there are a few different ways mounts can do this. The most basic type of mount is called an alt-azimuth, or alt-az for short. These mounts move in two directions: altitude, which is up and down, and azimuth, which is left to right. It's the same kind of motion you use when looking around with your own eyes. Alt-az mounts are popular for beginners and visual observers. They're intuitive, easy to set up, and great for planetary observing or lunar work. Some even include motors and go-to systems to help you find objects in the sky. But there's a catch. Because they don't align with the Earth's rotation, they suffer from a problem called field rotation. As an alt-az mount tracks a star, the orientation of the sky in your camera's field of view slowly twists. Over time, stars form arcs instead of points, ruining long exposures. This makes deep sky imaging impossible without additional help. To fix that, some alt-az mounts can be paired with an equatorial wedge. A wedge tilts the entire mount so that one axis aligns more closely with the Earth's rotation. With the wedge in place, the alt-az mount can mimic an equatorial mount, but it's a compromise. You'll reduce field rotation, but you may still need a field derotator to keep exposures sharp beyond a minute or two. So while alt-az mounts are fantastic for learning and good enough for planetary imaging, they're not ideal for serious deep sky astrophotography. Next up are equatorial platforms. These are unique tools often paired with Dobsonian telescopes or wide-field camera rigs. An equatorial platform is essentially a tilted base that moves slowly in sync with Earth's rotation. It gives your telescope or camera about an hour of smooth tracking. They're quiet, simple, portable, perfect for visual observing or short exposures. But their simplicity is also a limit. Most equatorial platforms lack go-to capabilities. There's no automation, no slewing to targets. After about an hour, you have to reset and start over. Still, for wide-field astrophotography or beginner-level imaging, equatorial platforms are a creative solution, just not a long-term one. Now we come to the backbone of modern astrophotography, the German equatorial mount, or GEM. This is the design you'll find in nearly every serious imaging setup, from beginner rigs to professional observatories. A GEM is built around a simple idea: align one axis of motion, the right ascension axis, with the Earth's own axis of rotation. When you polar align a GEM properly, it tracks the stars across the sky using a single smooth motion. This is critical, because it means you don't get field rotation, you don't need a wedge or a derotator. You don't have to fight the physics of the sky. The mount just moves in harmony with the stars. GEMs also support precise slewing, accurate go-to functions, and are highly customizable. They come in sizes ranging from portable travel mounts to observatory-class giants. So, if you're serious about imaging, especially deep sky astrophotography, a GEM is almost always the best path forward. Let's dive deeper. Inside every mount lies its most critical component, the drive system, a motorized mechanism that turns the mount's axes slowly, smoothly, and with extreme precision. And when it comes to how that movement is created, you'll mostly encounter two kinds of systems: the traditional worm gear and the newer harmonic drive, also known as strain wave gears. Worm gears have been the trusted workhorse of astrophotography for decades. Their core design is simple, mechanical, and refined over time. A screw-shaped worm meshes with a large gear to rotate the mount. It's smooth, controlled, and, when aligned properly with Earth's rotation, enables perfect tracking across the sky. But like all physical systems, they're not flawless. Tiny imperfections in the gear teeth, often just microns wide, create a slow, rhythmic wobble known as periodic error. Low-end mounts might drift 50 or 60 arc seconds over a few minutes. Premium models like the EQ6R Pro or the Ioptron CEM70 keep that error under 10. Still, it's always there. Thankfully, we've learned how to correct for it. The first layer is periodic error correction. The mount records its own motion over a few cycles, learns where it stumbles, and starts applying live corrections. It's not perfect, but it's smart. Add auto-guiding, where a second camera watches a guide star and nudges the mount every second, and you can bring most mid-tier mounts into the sub-arc second accuracy range. But there's another level beyond guiding and PEC, one where errors aren't just corrected, they're prevented. Enter encoders. These are ultra-precise optical or magnetic sensors mounted directly on the RA and deck axes. Unlike gears, they don't infer motion. They measure it in real time, hundreds or thousands of times per second. Mounts with encoders, like the 10-micron GM1000, the Astrophysics Mach 2, or Ioptron's HAE29EC, don't need PC training. There's no trial and error, just pinpoint tracking, often without auto-guiding, for minutes or even hours. These mounts are elite, engineered for observatory-level performance. Now, let's look at the other side of the mount revolution. Harmonic drive mounts, also called strain wave mounts, represent a newer, radically different approach. They're compact, lightweight, and portable. No big counterweights, no bulky housings. They use a flexible gear system that transmits motion through precise internal deformation. It sounds strange, but it works. There's almost no backlash, no mechanical slop. And for lighter setups, they're game changers. Mounts like the AM5, Pegasus NIX 101, and Ioptron HEM 27 are small enough to fit in a backpack and fast enough to set up and start imaging within minutes. But these benefits come with trade-offs. Unlike worm gears, harmonic drives don't create smooth, predictable periodic errors. Instead, they produce irregular, non-repeating deviations, making them harder to guide. Many models also have high static friction, especially in the RA axis. That means when your auto-guider sends tiny corrections, the mount might not respond, until tension builds up and suddenly snaps forward. The result? Jerky motion, star trails, and ruined exposures. We've seen this firsthand. Take Professor Vijay Sutar, a retired physics lecturer and lifelong tinkerer in astronomy and engineering. When his AM5 began showing erratic guiding in RA, oscillations, jumps, sluggish reactions, he tried everything. Retuning his PhD to settings, resetting firmware, contacting ZWO support. Nothing worked. So he opened it up. What he found was simple but revealing. The harmonic gear's wave generator was too stiff. It was under-lubricated and dry, resisting the fine motions needed for guiding. The deck axis was fine, but the RA axis had so much static friction, it was storing tension in the belt and releasing it suddenly, causing guiding to break down. He disassembled the drive, applied a few drops of machine oil into the circular gap around the wave generator, and spun it gently with an electric drill to work the lubricant in. The difference? Friction dropped from 1.5 kilograms to just 0.6. And his guiding RMS? It improved dramatically, dropping to a clean, consistent 1 arcsecond. This kind of hands-on tuning isn't exclusive to the AM5. In fact, it's becoming increasingly common across a wide range of harmonic mounts. Similar issues have cropped up with other brands too. Often it comes down to the same issue, friction. Harmonic drives are built around internal tension and perfect flexibility. But if there's resistance, dried grease, stiff bearings, uneven loading, they don't behave. They're precise systems. But that precision cuts both ways. So what does this all mean? Worm gear mounts are heavier, bulkier, and need more setup, but their motion is predictable, and their errors are easier to control, especially when you add encoders. They're still the standard for deep sky imaging. Harmonic drives, on the other hand, are lightweight, portable, and beautifully efficient. But they come with quirks. Guiding is more demanding, and in some cases, you'll need to do mechanical tuning right out of the box. Both technologies offer real advantages. Both have real compromises. So now that we've seen how mounts work and the real-world differences between worm gear and harmonic drive systems, what's the takeaway? What do we actually recommend? Let's begin with the classical path, the tried-and-true route that most astrophotographers have followed over the years. If you're just starting out with a DSLR or mirrorless camera and a wide-field lens, there's no better entry point than the Skywatcher Star Adventurer GTI. Compact and portable, this little mount punches well above its weight. It supports accurate sidereal tracking, carries up to 5 kilograms, includes go-to capability via SynScan, and can be polar aligned in minutes. Within hours, you'll be capturing Milky Way arcs and star trails with sharp, precise framing. Ready to step up? Maybe you're adding a small refractor or Newtonian to your kit. That's when the real German Equatorial mounts come in. Workhorses like the HEQ5 Pro or EQM35 Pro are industry staples. These belt-driven go-to mounts support payloads in the 10 to 13 kilograms range, and they've been around long enough to have battle-tested firmware, extensive community support, and every kind of tweak, mod, and field fix documented. They're not glamorous, but they get the job done night after night. If you're aiming higher, with heavier optics and longer exposures, then the legendary EQ6R Pro is your next logical step. With a 20 kilograms imaging capacity, a low periodic error curve, and excellent guiding response, this mount has been the backbone of countless serious rigs. From broadband galaxies to narrowband nebulae, it delivers, and thousands of forum threads and YouTube guides prove it. But maybe you're not just after performance. You also want portability and minimal fuss. That's where the new generation steps in with the likes of the ZWO AM5. This mount uses a harmonic strain wave gear system. No counterweights are needed for small scopes. It's light enough to fly with and sleek enough to set up in minutes. But remember, harmonic drives don't naturally dampen periodic error. They must be guided and may require careful tuning for top-tier performance. If you're running a larger rig, the Ioptron CEM70 is a standout in the center-balanced category. With up to 32 kilograms of imaging payload, precision machining, and optional high-res encoders, it offers serious performance in a stable, reliable frame. And if you're building a backyard observatory, the EQ8R Pro stands tall, literally. Designed for permanent installations, it features belt drives, massive capacity, and near-zero backlash. It's the tank of Skywatcher's line. At the very top end, we enter the realm of true precision, 10-micron GM1000, Astrophysics Mach 2 GTO. These mounts aren't just premium, they're fundamentally different. With absolute encoders and advanced modeling, they can track unguided for minutes or even hours within sub-arcsecond tolerances. In many setups, they eliminate the need for guiding entirely. This is only the classical playbook. Still works, still reliable, still delivering stunning images night after night. But the game is changing. If you've seen our telescope guide, you already know. Astrophotography is in a golden era of choice. And now, the same revolution is hitting the mount market. Across backyards, Discord channels, and imaging forums, a quiet revolution is building. The harmonic drive mount, once a boutique curiosity, is becoming mainstream. And behind the scenes, a new generation of manufacturers, especially up-and-coming companies from China, isn't just copying. They're innovating. Take the ZWO AM5. It costs nearly half of what an AM5 does, but features a real strain wave drive, whisper-quiet motors, and fully integrated go-to support via OnStep. Though it required some tinkering, from what we've heard across the community, there's also support available to help you fix and dial it in. And if you think about it, even the AM5 from a reputable brand often needs tuning, with far less openness when it comes to support. At half the price and with solvable quirks, it's an unbeatable value. Then look at the Warp Astron WD-20P, a premium harmonic system that pairs strain wave drives with brushless servos and onboard high-resolution encoders. It fully eliminates backlash and delivers guiding RMS as low as 0.3 arc seconds with capable setups. There's active thermal regulation on the RA axis, dual USB-C ports with up to 150 watts of pass-through power, and full support for automated sequencing tools. All in a 5.7 kilograms mount that can carry up to 30 kilograms with counterweights. It's not just portable, it's precision gear you can travel with. And then there's EM31 Pro from Mcanastro. With a dual-mode EQ and Alt-az design, dual harmonic drives, and a lightweight carbon fiber body, it supports payloads of up to 20 kilograms with counterweights. Features like Wi-Fi, Bluetooth, cable pass-through, and compatibility with ASI, Air, and Nina make it highly integrated. While it hasn't outperformed the AM5 in extended unguided tests, it has shown impressive tracking stability and is quickly earning a reputation among advanced imagers. So what's the takeaway? Harmonic drive mounts are no longer niche. They're the new normal. And the newest manufacturers aren't just catching up, they're pushing boundaries. Performance is rising, prices are dropping, and access to high-end imaging is becoming easier than ever. But this story isn't just about what's coming out of factories. It's also about what's being built at home from scratch. Because today, with the right parts and a bit of know-how, you can build a harmonic mount yourself, often for a fraction of the cost. Earlier, we met Professor Vijay Sutar, who pinpointed and solved guiding issues on his AM5 with quiet precision. But that wasn't the end of his story. When an electrical fault crippled his Ioptron CEM70G, he didn't give up. He rebuilt it completely. A custom on-step controller, off-the-shelf USB hubs to replace the failed originals, a full electronics retrofit now fully controlled from a smartphone. The total cost? Less than $60 USD. Compare that to more than $1,200 for official replacement parts from Ioptron. Diagnose, adapt, improve. And he's far from alone. Across the globe, makers and engineers are turning to open source platforms like OnStep, reviving old mounts or building new ones entirely from scratch. And they're doing it at a fraction of the cost of traditional brands. The result? A quiet revolution, one that's making advanced astrophotography gear more affordable, more approachable, and more personal than ever before. At Edisla, we don't just talk gear, we test it, break it, fix it, and use it under real skies. So, before you pack up for your next session, here are a few recommendations that make the difference. Because the mount isn't just part of your setup, it is the foundation. First, polar alignment. It's not optional. It's everything. Use SharpCap, ASI Air, Polemaster, or Nina's polar tools, whatever works for you, but aim for less than 5 arc minutes of polar error. If you're using a harmonic drive, get under 2 arc minutes. That's the margin between elongated stars and round ones, especially at longer focal lengths. Second, balance. Even with modern backlash-resistant systems, mechanical balance still matters. Balance east-heavy on the RA axis, just slightly. This keeps the tracking gear always engaged. On the deck axis, balance front to back based on camera, focuser, and dew gear position. Remember, don't let motors push weight uphill. Let gravity assist your guiding. Third, payload limits. Manufacturers advertise maximum capacities. You shouldn't be pushing those. For best guiding, aim for 60–70% of the mount's rated imaging capacity. That includes telescope, camera, filter wheel, focuser, dew heaters, and even cables. A lighter load gives your mount breathing room and your guiding software better control. Fourth, periodic error correction. If your mount supports it, use it. PAC records the imperfections in your RA worm gear over 1 or more rotations and pre-corrects for them. Some mounts support real-time PC like 10 micron or astrophysics. Others, like the EQ6R, require a recording session. Either way, it's worth it. Combine it with auto-guiding for the best of both worlds. Fifth, auto-guiding setup. Use a proper guide scope, one that's rigidly mounted with decent focal length for your setup. Calibrate near the celestial equator and meridian. Avoid aggressive guide settings. Aim for smooth corrections, not sharp overreactions. And always dither, especially if you're shooting deep sky targets. Dithering shifts your field slightly between exposures to eliminate fixed pattern noise during stacking. Sixth, cable management. One of the most overlooked causes of tracking failure is cable drag. Don't let it happen. Route cables carefully. Use flexible strain reliefs. Keep cables away from moving axes. If your mount supports pass-through cabling, use it. This includes mounts like the Canastro EM31 Pro or newer Harmonic designs with internal USB and power. A single snag can destroy an entire night's worth of data. Seventh, temperature and environment. Your mount lives outside. Dew, frost, dust, they all matter. Keep connections sealed, power stable, and motors protected. If you're operating in extreme cold, note that some Harmonic drives stiffen up. So let them acclimate before starting. And if your mount has thermal regulation, like the Warp Astron WD20P, don't disable it. Eighth, know your mount. Learn its language and watch the RA and deck guiding graphs in PhD 2. Listen to the sound it makes when slewing, tracking, correcting. Over time, you'll feel when it's happy and when something's off. That's how you go from operator to expert. Because in astrophotography, your mount isn't just hardware. It's the difference between stars and streaks, between beauty and blur. Your telescope collects light. Your camera records it, but your mount? It holds the sky still. So whether you're just starting out with a Star Adventurer GTI, stepping into precision with an EQ6R Pro or AM5, or pushing the edge with a custom on-step or encoder-driven dream machine. Remember, it all begins here with a controlled, stable, precise motion. Thanks for joining us at Edisla on this deep dive into mounts. If you've made it to the end, thank you, and don't forget to share your thoughts in the comments.